Let's go to LeetCode 1793. Maximum score of a good subarray. For this question, it gives us integer nums and index k. And let's try to find the maximal possible score of a good subarray. So the score is defined for this kind of subarray, the minimal value times its width, let's say j minus I plus 1, right? J is the right and index, I is the left hand index. And it has the good subarray need to have I smaller equal to k and j greater equal to k. And let's try to find the maximal value. Intuitively, we think about it, we use the two for loop for I from k to 0 and j from k to n minus 1, right? And for every for loop, we try to compare the minimal value if we in the inner for loop and try to update the result, calculate the local result and update the global result, but that will be O n square time complexity. We know this kind of length is 10 to the power 5, so we can think about some beta approach. Let's look at this array, right? Initially, this is k, right? And both I and j point to this k, right? So in this case, if we move one step, can we have some better approaches or strategies? For example, we can look at nums I minus 1, right? And nums j plus 1 to see which one is greater, right? So if we have, for example, nums j plus 1 greater than nums I minus 1. So if we move one step, the beta strategy for us is move the j index, right? Because this number is greater. And we expanded the width for one step, right? And we'll say if we move one step, this kind of area will always be greater than one step of this area, right? So so in this case, we compare, for example, the I index and the J index, trying to see what's the next, what's the value on its right, and what's the value on its left. So we'll find moving the right, the index, which will have greater value, will always be optimal. So in this case, what we can do is that we can, for example, if we have nums I minus 1 is smaller than j plus 1, right? So we have we have this I being fixed and moving j, right? Until in a scenario that we have nums I minus 1 greater, right? Greater than nums j plus 1. In that case, we'll move the left pointers, right? Of course, we can put the equal sign to either the up or lower. So in that case, we will have our I and j just moving like two opposite pointers. They will never go back. And until either I or j is at the end, then we go the rest of the pointer to finish the for loop. And every time we move I or j, we have a local score, and comparing that with the global score. So let's begin to write code for this. We'll have in equals nums dot length, right? And we'll have I. This is the left pointer equals k, and the j equals k is the right pointer, right? So we'll have a minimal value, right? For this subarray. At the beginning, this minimal value will be nums k, right? And now both left pointer, right pointer, they point to k. So the width of the range is 1. So we'll see the local area, that will be nums k, right? Or you will say nums k multiplied by 1, right? So the result is a global max will also be nums k, right? So we'll write while n greater than 0 or I. That's the left pointer, we still have a space to move, or j smaller than I minus 1, right? That is the right pointer still have space to move. So we'll say if we use if because we move step and one step, then we check the while, right? Then so that we can jump out of the while loop. When we jump out of the while loop, that means both I and j, they are at the end, right? I is at 0, y j is at I minus 1. So we'll say if I is already equal to 0, right? That means on the left, we don't have space to move, or I doesn't equal I still have space to move, but we have nums j plus 1 greater than nums I minus 1, right? In this case, we need to make sure the j will not go out of the range. So we'll have j plus 1 smaller than and right? So in this case, we're going to have move the right pointer. Else, we'll just move the left pointer, right? So we'll see if we move the right pointer, this number will be the only number which will be added to our range, right? So we'll have minimal equals max dot main and this value, right? And in the meanwhile, if we move the left pointer, we are also add one value to our range, right? So we may also apply to our main. So we'll say after one step move, we need to get a local area equals main multiplied by j minus I plus 1, right? And for every step, we also need to compare the result. And in the end, we just return result. The time complexity will be O(n). Space is constant.